Hey, good day everyone. This is Engineer Rosel Verdadero Babalcon and I will be discussing about the seismic load analysis in accordance to NSCP 2015. So these are the topic objectives: selection of method of analysis, description of analysis techniques, modeling considerations, system regularity, load combinations, other considerations, drift computation and acceptance criteria, and P-delta effects. So these are the load analysis procedure. First is determine the building occupancy category. Second, determine basic ground motion parameters. Number 3, determine site classification. Number 4, determine site coefficient adjustment factors. Number 5, determine design ground motion parameters. Number 6, determine seismic design category. Number 7, determine importance factor. Number 8, select structural system and system parameters. Number 9, examine system for configuration or irregularities. 10, determine diaphragm flexibility if it's flexible, semi-rigid, or rigid. 11, determine the redundancy factor. 12, determine the lateral force analysis procedure. 13, compute lateral loads. 14, add torsional loads as applicable. 15, add orthogonal loads as applicable. 16, perform analysis. 17, combine results. 18, check strength, deflection, and stability. Okay, so first step is to categorize our building. In what occupancy category does it belong? So there are 5 occupancy category, naming number occupancy category 1, the essential facilities. Number 2, the hazardous facilities. Number 3, special occupancy structures. Number 4, standard occupancy structures. And number 5, miscellaneous structures. And these are the corresponding occupancy or function of a structure in regards to the occupancy category. So for essential facilities, those are facilities including for hospitals, for power and communication and transmission lines, fire and police station, garage, and shelters for emergency vehicles and emergency aircraft. So basically, the essential facilities are structures that is essential in times of a calamity or in times of a natural disaster. Okay, that is expected to function even after the event of a catastrophe. So those are hospitals, emergency structures, and other structures used for evacuation purposes. Number 2, occupancy category 2 is the hazardous facilities. So those are occupancies or structures that is expected to have explosive or chemical substances that is prone to explosions. Number 3 is the special occupancy structures. These are structures that have a big amount or big number of occupants, like for example, buildings with an assembly room with an occupant capacity of 1,000 or more, and churches, mosques, and other religion facilities. Okay. Number 4 is the standard occupancy structures. All structures housing occupancies or having functions not listed in category 1, 2, 3, and category 5. So technically, most residential houses are categorized as standard occupancy structures or occupancy category 4. And number 5 is the miscellaneous structures or the private garage, carports, sheds, fences over 1.5 meter high. Okay. So this building occupancy category can be found in the table 103-1 of the NSCP. So number 2 is the ground motion parameters. So Philippines is divided into 2 seismic zones, Zone 2 and Zone 4. Zone 2 covers the province of Palawan, except Busuanga, Sulu, and Tawi-Tawi, while the rest of the country is under Zone 4, as shown in the figure 208-1. So majority of the Philippine area is under category seismic zone 4, which corresponds to a seismic zone factor of 0.4, and the rest under seismic zone 2 has a seismic zone factor of 0.20. Now, for the seismic source types, we need to identify the nearest fault fault line in our site location, and we need to identify the maximum moment magnitude that fault line produced in the past or based on history. So we can identify the seismic source type of the nearest fault line near our site location. So we have three seismic source type. We have seismic source type A, B, and C. So seismic source type A are those faults that are capable of producing large magnitude events and that have a high rate of seismic activity. So the maximum moment magnitude for seismic source type A is 7 to 8.4. For seismic source type B, those are all faults other than types A and C. So it's around 6.5 to 7 is the range of the maximum moment magnitude. And for seismic source type C, the maximum moment magnitude is less than 6.5. Okay. So after we have known the seismic source type of the fault line nearest our structure, okay, let's proceed to the site soil profile type. Okay. Back to the seismic source type, if ever there is a chance that your site is in between seismic source type A and C, okay, but is nearest to seismic source type C and farthest to seismic source type A, we should consider computing also for the seismic source type A, whichever that will produce a higher amount of shear in our computation later on. Okay. So for the soil profile type, we need to classify our soil based on the soil profile type. So each site location has a specific geotechnical data which must represent a soil profile type. So we have soil profile type category as A, S, B, S, C, S, D, S, E, and S, F. So for SA, its description is a hard rock, SP is rock, SC is very dense soil and soft rock, SD is stiff soil profile, SE is soft soil profile, and SF is soil requiring site-specific evaluation. Okay. If geotechnical engineering report or data is not available, we can use the SD or soft soil profile type SD or stiff soil profile for the assumption of the soil profile type in our location. We cannot use soil profile type E or the soft soil profile or SF. If we are going to use those type of soil, it needs to have an equivalent geotechnical data that will determine that it is the soil profile type of our location or our site. So again, we can assume if ever there is no available geotechnical engineering data, we can assume the soil profile type as SD. So these are the design ground motion parameters for seismic zone 4. We have the near source factor and the seismic response coefficient. These are found in table 2085, table 2086, 2087, 2088, and NSCP 2015. So for the near source factor, we have two. We have NA and NV. After we have identified the seismic source type, we have identified our distance, the site distance to the nearest fault line. Okay, we can now identify the factors, near source factor NA and NV. Okay, for example, our seismic source type is A and our distance to the seismic source type A is 15. So that's greater than 10 kilometers. Therefore, our near source factor NA is equivalent to 1 here. And for example, seismic source type is A and our distance to the nearest fault line seismic source type A is 15 kilometers. Therefore, our NV value is also 1. Okay, for the seismic coefficient CA, so let's say we have identified our soil as soil profile type SD. So we are in zone 4. Therefore, our CA value is equal to 0.44 NA. or 0.44 times 1 is equal to 0.44. And for the CV, which is found in table 208-8, so again, we assume that our soil profile type is ST and we are located in zone 4. So our CV value is 0.64 NV or 0.64 times 1. That's equivalent to 0.64 as the value of the CV. Okay, now for the importance factor which can be found in table 28-1, the seismic importance factor. A while ago, we have identified the occupancy category. Let's say our occupancy category for a school building is a special occupancy structure for a college school building. So therefore, the seismic importance factor will be equal to 1. And also for I sub P is equal to 1. The purpose of the importance factor is to add strength to the structure, in relevance to its importance or its function after a severe after a calamity. Let's say for essential facilities, these are facilities that is expected to function after an earthquake or after an event. Okay, so using the importance factor, it is 1.5. So importance factor is a multiplier to the computation of the base shear. So multiplying the base shear to a value of 1.5 will increase the amount of base shear by 50%. Okay, so that is the computation that we assume, that is assumed by the code to consider in terms of the risk. Okay, and also to add strength to our structure. That's why if you see two buildings that is categorized as standard, let's say special occupancy structure and essential facilities, you will see that essential facilities has a greater amount of reinforcements or greater gross area of the structural members. Okay, or maybe more stringent amount or more conservative value in terms of in the connections. So the connections is more rigid. Okay, so that is the effect of increasing the amount of shear by 50% using the importance factor for essential facility to add strength to our structure. Okay, so there are several types of structural system. We need to identify the structural system that we are going to use. Okay, so each structural system has an advantage and disadvantages in the performance of a building and also in the economical aspect and also for the aesthetic aspect. So we need to balance those three in selecting for the structural system, the structural strength or the strength of our structure, the economical aspect, and also the aesthetic aspect. So these are the typical structural system here in the Philippines. So each structural system has a corresponding system parameters, which are the response modification factor or the R value, the system overstrength parameter, and the height limitation depending on the location of your site. So later on we will discuss this. So we have the bearing wall system, building frame system, moment resisting frame system, dual system with SMRF, dual system with IMRF, ordinary shear wall frame, interactive systems, cantilevered column system, and steel systems not detailed for seismic. So these are the common structural system. We have the bearing wall, building frame, moment resisting frame, and the dual system. The difference or the logic behind this type of system is how the lateral force resisting system will resist the vertical and lateral loads or the gravity or lateral loads of the structure. Okay, if which part of your structure will resist those type of load will determine if what is your structural system. Okay, so for the bearing wall, which can be found on section 208.4.6.1 in NSCP, it is a structural system without a complete vertical load-carrying space frame. So the bearing walls or the bracing system provide support for all or most gravity loads. So resistance to lateral load is provided by shear walls or braced frames. So typically, bearing wall system are those system which consists of wall on which the wall will resist the gravity and the lateral load. Gravity loads consist of the live load and the dead loads, while the lateral loads consist of the seismic loads and the wind load. A bearing wall system is advantageous for low-rise structure because it is easy to construct, so it's work and it is faster to construct for low-rise structure. But the R value is around 2.8 to 5.5. So it lacks redundancy. So bearing wall system may be a masonry shear wall, or it can be a reinforced concrete shear wall, or it can be a cross bracing in steel. Okay. And also it can be a load-bearing masonry wall. Okay. So bearing wall system is typically used in low-rise residential buildings. Okay, so it's prevalent in almost all residential low-cost housing because it is more affordable for low-rise structure and it's easier to construct. Okay. But the downside of the bearing wall system is that it limits the amount of opening for the walls and doors because the wall is expected to function to resist the external loads. So adding an opening to the wall will lessen the strength of the wall. That's why the disadvantage of this system is that it does not allow a lot of openings. Okay. Next is the building frame. So a building frame is a structural system with essentially complete space frame providing support for gravity loads. And the resistance to lateral load is provided by the shear wall or braced frame. So here in this figure is an example of the concept of a building frame. The gravity loads is carried by the space frame or composed of the column and beam connections, and the lateral load is resisted by the shear wall or braced frame. So there are two types of system. So unlike the bearing wall, the gravity is also resisted by the wall alone. Here in the building frame, only the lateral loads is resisted by the shear wall or braced frame or the bearing wall, and the gravity loads is resisted mainly by the space frame. So this needs to consider the deformation compatibility. The R values varies from 5.5 to 7. Okay, next is the moment resisting frame system. A moment resisting frame system is a structural system with an essentially complete space frame providing support for gravity loads. So moment resisting frames provide resistance to lateral load primarily by flexural action of members. So moment resisting frames is the usual type of system that is used in the seismic zone 4 here in the Philippines because of the flexural action of the members. The moment resisting frame has a high value of the R value or the redundancy factor. The response modification factor R. It's around 3.5 to 8.5. And also the advantage of the moment resisting frame is that it allows more openings, okay, for the architectural requirements, specifically for commercial structures. So it's more advantageous for the architectural aspects of the structure, and also it has an excellent performance in terms of its seismic response because of the high R value or the response modification factor. It has a high level of ductility and redundancy. That's why most designers is using moment resisting frame system for commercial buildings and high-rise structures. The gravity and the lateral loads is supported by the space frame. Okay, the lateral loads is resist by the frame also by flexural action. So there will be moment, okay, in the connections of the space frames. So it is expected that in moment resisting frame system, the amount of reinforcement is more detailed compared to other type of system because of the expected resistance of the frame to the lateral loads. And next is the dual system. So it is similar to building frame system, except the gravity frame also provides secondary lateral force resistance. So in the building frame, the gravity load is supported by the frame. But here in the dual system, the gravity and the lateral load is also resisted by the frame system. So it's like a combination of the moment resisting frame and the building frame system. Okay. So the moment resisting frame in the dual system, or the frame in the dual system, should be designed to resist at least 25% of the design base shear. It also has a high value of the response modification factor, around 4.2 to 8.5. And there are other types of structural system. Okay, that is the cantilevered column system, the undefined structural system, non-building structural system. Okay, so for height limits in table 208-11, here, this is the table 208-11, or the earthquake force resisting structural system. In this table, we can find for the R value, corresponding R value, and the system limitation and building height in a specific seismic zone factor. For example, this is a table for concrete. So let's look for here. So for special reinforced concrete moment frames, we have R value of 8.5, and it says here for zone 2, the height limit is no limit. So there is a no limitation for the height when we are going to use a special reinforced concrete moment frames. But if we are going to use a special reinforced concrete shear walls, the R value is around 4.5. So notice that the R value is lesser for bearing wall system. And for zone 2, there is no limit for the height. But when you are going to use this type of system in seismic zone 4, the height limit will now only be limited to 50 meters. So in terms of meter. And if it's going to be an ordinary reinforced concrete shear wall, it is not permitted to use this type of system in zone 4. Okay, so for special reinforced concrete shear walls, okay, under dual system, the R value is 6.5 and the height limitation is 50 meters in zone 4. So for ordinary reinforced concrete shear wall, it is not permitted in zone 4. And for cantilevered column system, under zone 4, okay, so the R value or the response modification factor is around 2.2 only. So the limitation of the height in seismic zone 4 using the cantilevered column system is only 10 meters. So that is how you are going to use this table. So that is why most designers prefer to use special reinforced concrete moment frames, because it has no limitations when it comes to the height in seismic zone 4. But there are also other types of system that you can utilize in seismic zone 4. You just have to refer to this table. We also have for steel, okay, for steel, and for, okay, another one for steel, and for masonry. So for masonry shear walls, the redundancy factor is R and the height limitation is 50 meters for seismic zone 4. And also for wood, okay, so here are the other system for wood. Okay. So the response modification factor accounts for the ductility, overstrength, redundancy, damping, and past behavior of your structural system. The response modification factor is listed in Table 208-11 that we have discussed a while ago. You can compute for the response modification factor, or you can also refer to the table, to the value listed in Table 208-11. Okay. Using the response modification factor, here is the shaded region, the red region, okay, shaded red region without the response modification factor. So you can see that the lateral displacement is around this value, and the base shear, okay, the strength, lateral strength of the structure is around here, okay, at this point. But if you are going to use the redundant response modification factor, the base shear that we are allowed to design our structure will be reduced, and also the lateral displacement or the lateral displacement of our structure is expected to increase. So that is the performance of our structure because of the response, because of using the response modification factor. The shear of our structure is reduced, but the lateral displacement of our structure is increased. So the lateral displacement allowed for our structure is greater, okay, because of the ductility. Take note that the response modification factor accounts for the ductility of our structure. So the greater the R value, the more ductile our system.